Hello, this is Joita Ghosh. I would like to start by telling you to imagine reading a sentence word by word, like the movie started slowly but the ending was excellent. Now, if I ask about the ending, our brain immediately focuses on the word excellent, not on started slowly. So, this simple ability, deciding what to remember and what to ignore, is exactly where early neural networks struggled. Today, I will explain how sequence models evolved from RNN to LSTM and GRU by learning to control memory. Now, why sequence modeling is hard? Sequential data is different from images and tables. We can take text data as sequential data, and here the figure visualizes the example I mentioned earlier. In sequences, context matters, and sometimes the most important information appears far away from the current position. So, a model must answer a difficult question at every step. Should I remember this information or can I forget it? Early models tried to solve this problem, but not very successfully. So, the recurrent neural network or RNN was the first attempt to model sequences. Its idea is simple. Each time step takes the current input and the previous hidden state and passes information forward for short sequences. This works well, but as sequences grow longer, important information slowly fades away. The RNN has memory, but it has no mechanism to decide what is important. In other words, it remembers everything equally, and that turns out to be a big weakness. To fix this problem of long sequence, we have long short-term memory or LSTM. The key idea of LSTM is memory control. Instead of blindly passing information forward, LSTM introduces a memory cell and several gates. These gates decide three things: what information to store, what information to forget, and what information to use for output. As we can see in the figure, we have forget gate, input gate, and output gate. We can think of LSTM like a smart notebook. It keeps important notes and erases irrelevant ones. This design allows LSTM to handle long-term dependencies much better than a simple RNN. While LSTM is powerful, it is also complex and computationally heavy. This led to the gated recurrent unit or GRU. GRU simplifies LSTM by reducing the number of gates and removing the separate memory cell, which is clearly seen in the figure of GRU. So from the figure of GRU, we can see two gates. One reset gate and another one is update gate. Update gate combines the input gate and output gate. Besides, the reset gate decides how much past information to forget. Despite being simpler, GRU often performs very similarly to LSTM in practice. We can think of GRU as a light version of LSTM, faster to train, easier to implement, and still effective. Now, if we compare all three models conceptually, RNN has no memory control, LSTM has strong and explicit memory control, and GRU offers a balanced compromise between complexity and efficiency. The evolution here is very clear. It's not about the networks deeper, but about managing information more intelligently. To conclude, sequence learning is fundamentally a memory management problem. RNN showed us that recurrence is possible. LSTM taught us how to preserve long-term information. GRU showed that simplicity can still be powerful. So, successful sequence models are defined not by complexity but by how well they control memory. So, that's all. Thank you very much for listening me.